Then shall we start?
Yes, sir.
Shall I start?
Yes, sir. Yes, sir.
Okay.
Welcome to again session 1 of third series of the online STTP. AICT sponsored short-term training program on electromagnetics, microwaves, RF and antenna design. So in this particular session, Dr. A. Prakash Rao sir from NIT Warangal is going to deliver his lecture on optimization techniques in beamforming. So I request Priyanka to give this introduction about today's speaker, and then we will start.
Okay.
Priyanka. Hello, Priyanka.
Is it audible, sir?
Yes,
Yeah,
yes.
yes.
Good afternoon, sir. I take it as my privilege to introduce Dr. A. Prakash Rao, sir. He obtained his bachelor's degree in ECE from Nagarjuna University, Andhra Pradesh, and he obtained his master's degree from Pondicherry University, and he had a specialization of electronics and communication engineering for both his master's and his bachelor's, and he completed his doctoral degree in just a minute. National Institute of Warangal, India, in the year 2018, and he had more than 22 years of teaching experience in various organizations. Currently, he is working with Department of Electronics and Communication Engineering as associate professor at National Institute of Technology, Warangal, and he have published around 20 papers in various international and national journals and conferences. And his areas of interest mainly include signal processing, smart antenna systems, optimization techniques, and he's a life member of ISTE and a member of IEEE, and he had taught many subjects for UG and PG subjects like EDC, pulse and digital circuits, signals and systems, probability theory, communication systems, digital electronics, linear integrated circuits, and so on. And he had guided more than 40 UG and PG projects, and currently he is guiding 2 research scholars under his supervision. Prakash Rao sir also conducted various faculty development programs like on electronic devices and circuits, analysis and design of electronic circuits, optimization techniques, and in antenna design. analog electronics workshop, metamaterial antennas and optimization techniques, metamaterial applications and evolutionary techniques. And he is also holding many administrative responsibilities at institution level as well as at department level. And he is department PG ACS coordinator for 4 years, and he is department ECE association faculty advisor for 3 years, department UG by PG DSC member till date, department timetable in charge till date, and associate dean academic for 2 years.
Thank you, madam.
And cordially welcome you, sir. Sir, it is great privilege to have you here, sir. And sorry for the break what I have
Okay, sir.
taken.
Thank you, Priyanka. Now I request Prakash Rao sir to take the session.
Thank you, sir. Right. Thank you, sir. Good afternoon to all. Very happy to see you through online for attending such workshops, especially in antennas domain. And today we are going to see optimization techniques, importance, and how to utilize these techniques in beamforming, especially. The last section, we discussed about optimization techniques, LMS, and GA and all, the importance and role of that. Today we are going to concentrate GA, PSO, then Taguchi, and so on, and D. Based on the time, I will try to cover all these concepts. So before going to see the today's section, we'll recollect what you have discussed the last section briefly. Then we'll see the continuation of that last section. From the optimization technique, this is a well-known word. Every day we are using this terminology in our day-to-day life also, when you're going to discharge your duties systematically. And those are going to use these optimization techniques, they're very comfortable, and they are unable to utilize these techniques, then they are in trouble. Whether you know it or not, these techniques are involved. So if you are going to utilize effectively, and you can get the best solutions in a short interval. That is the reason we are going to use these techniques in a beamforming also. So how to utilize these beamforming techniques in our antenna domain, that we are going to see in detailedly. The outline of my presentation concentrates on motivation, problem statement, introduction, optimization techniques, and different algorithms we are going to see. Then finally conclusions and references. Then motivation, based on the application, we are going to pick up the different geometries. If you consider the dipole antenna, it will radiate signal in all the directions. But certain applications, this is required. But certain applications, we don't want to use this dipole antenna. If you go for the AM, All India Radio broadcasting, or FM broadcasting, then we need all the directions should be radiated. But if you go for cellular mobile communication, and when you are trying to develop the link between point to point, and I don't want the radiation in all the directions. For GP applications, again, we need all directions to be radiated. So based on the applications, we have to select the antenna structures. Then to study the space, to probe the space, then we are going to arrange the Hughes structure antennas in a systematically, and we are going to study it. Then you can see here, the signal is radiated in all the directions. And certain applications we need, but especially when you go for a mobile communication and radar applications, and we don't want to radiate in all the directions. So when you are trying to use the directional antenna, and we are going to focus the entire energy systematically in a particular direction, then that is not enough. When you are trying to use a directional antenna in a real-time applications, your radiation pattern is keep on changes. Dynamically it changes based on the user demand. So the user is not constant location, he can move. So accordingly, the link should be modified. So your beam should be steered. And not only that, you have to place the nulls whenever the unwanted signals are coming in a particular direction, in that particular direction. So we need to control radiation pattern more effectively. So to do that, we are going to use optimization techniques. So with the help of the optimization techniques, we are going to achieve beamforming control. Then beamforming, smart antenna beamforming techniques versus omnidirectional antennas. So using beamforming, we will get the high gain. I'm not going to take much time. So coverage area is going to be increases and less number of antennas are required. And side lobes are going to be minimized or controlled, or it can be cancelled, and null can be placed or it can be steered. So with that, signal to noise ratio is going to be improved, and that will lead to channel capacity improvement. And with the help of side lobes and null steering, interference is going to be controlled or minimized to some extent. Then due to directional sending, energy can be saved, the battery life can be improved. Then similarly, you can see that in SDMA, space division multiple axis, the capacity is going to be improved with the help of diversity gain, n-fold diversity gain. Then another feature is multipath mitigation. This is very, very important to minimize the delay spread. So because we are going to receive the signals, direct signal along with so many multipaths. And due to that multipath, the distortion may occur, maybe phase or amplitude distortion. So to avoid that, multipath should be controlled as mitigated. So that is possible with the help of beamforming. So this technique is used in a radar, not only that, in mobile communication also. Then we are going to use these features in a MIMO platform, especially in 5G and 6G. People are going to use this beamforming techniques to improve the performance of the system. Then another feature is location, geolocation services. So to enhance these features, so you have to estimate the angle of arrival and direction finding. So that is possible with the help of smart antenna beamforming. So with this, we'll get so many benefits, and you can have a good control and good command on the radiation pattern. Then we have to see that 5G, 6G communications. I'm a little bit fast because already these things are discussed in the last section. Okay. So why you're going for 5G and 6G means we can see that today so many features are offered by the what you call service providers, but people are not happy. And with this, the data speed is tremendously increases, and you have to provide that much speed. Then only it is possible to have a streaming and all. If the speed is less and the streaming is not possible, so with all these features, at present, 10 gigabits per second data rate is to be needed. So that is possible with the help of 5G or beyond the 5G techniques. So another one is capacities is demanded lot, and another application is a low latency. This is another important feature, especially when you are trying to use driverless cars on the roads. Then the latency is a very, very important parameter. Latency means just delay. You are transmitting and you are going to receive back, and how much time is taken, and that time should be in the order of 1/1000 seconds. It should be very, very less. If it is latency is high, then we can't have a good or you can safe driving on the roads. It is not possible because you have to take the decision in a fraction of a second. On opposite vehicles are coming or something is coming, you have to take the left, right, and forward. What are the decision based on the road conditions? You have to take instantaneously. When the driver is not there, your system should be able to take the decision instantaneously without delay, and that is possible with a low latency only. And if you want to get the low latency, the present generation mobile technology is not possible. So 1G, 2G, 3G is not possible to get it. So when you are going to use the 5G and beyond 5G, then only it is possible to have a driverless cars. And not only that, quality and the bandwidth and battery life, especially IoT applications. Your IoT system is very, very compact and very small, and it demands low power. Uh, so it needs to, when it is very small and very compact, and your batteries demands frequently recharging. One has to recharge it frequently, but that is not possible. So you have to improve the lifetime of the battery. So that is possible with the help of 5G techniques, and coverage is going to be increased up to 100%. Then these are the other features. It can be applied in healthcare and robotics and industrial and so on. High connectivity, right. Then approaches, classical methods, evolutionary techniques, and hybridization techniques. Then you can see that list of some of the heuristic algorithms. You can go through this all these things from the list. We can make one conclusions. All these things are based on the nature behavior. So if you are going to observe the nature very closely, you have to observe very closely, then we can get the ideas. From that ideas, we can also develop the new algorithms, or novel algorithms can be possible. Is that clear? So if you see that ant algorithm, then monkey algorithm, firefly, bat algorithm, then TLBO, Taguchi, genetic, cuckoo algorithm, raindrop, particle swarm optimization, differential evolution, genetic algorithm, then evolutionary programming, all these things, fish algorithm, bacterial foregrowing optimization. If you take all these algorithms, they got it ideas when they are observed the nature very closely. So your surroundings, your atmosphere, what is going on. If you observe the your surroundings, your nature closely, then we'll get the so many ideas. So at this point of view, I would like to request all of you, because all are teachers, so you have to motivate your students to observe the nature very closely. They have to monitor. Simply seeing is not enough. So something you want to find is something you want to do, and they have to observe very closely. Not only these algorithms, so they want to solve some solution for the problem, existing problems. The boy should observe closely the system. When they are going to observe the closely, and the problem is analyzed thoroughly. Once the problem is analyzed thoroughly, and the problem itself will give the solution to the problem. So we no need to find the solution somewhere else. This is the way you have to teach. The solution is there in the problem itself. So you have to address to the boy in such a way that, so ask them to watch, ask them to observe carefully, not simply watching, carefully. If you monitor very closely, and if you study the problem very closely, then the problem will help you a lot, and to get the better solution. So all these algorithms are like that only. If you observe the closely, and you'll get the excellent ideas, excellent ideas. Then you can see that once you observe the nature very closely, or once you study the problem, and you can also get the new ideas. And after getting, you can propose the new algorithm, Reddy algorithm, Krishna algorithm, Soma algorithm, Lata algorithm, Rahu algorithm, like that, based on your name. So there is no wonder in that. But before going to publish your algorithm, one has to be certified. Yes, this is correct, is suggested. Tomorrow you are going to encourage to your boy, and your boy has come up with some modified algorithm, novel algorithm. How to testify that, how to validate it. So before going to apply in a specific application, boy has to verify these test functions, at least half a dozen. He has to pick up based on the problem, based on how he has developed, so where it is suitable. So ask them to verify these test functions, and check it whether the performance is giving nicely or not. How can you verify this? You go through the literature, and from the literature you can get it. In the literature, they said, say for example, one function, Rosenberg function. You have the mathematical equation, and what is the minimum value? Where we'll get for what parameter values? My Rosenberg will give you minimum value. So to get the minimum, I don't know what is the minimum, and where it will get also I don't know. I have the function, and my x and y varies from 0 to 5. Say x is varying 0 to 5 and y also varying 0 to 5, and I want to get the minima, and you have to apply trial and error method, and you have finally will get the minimum value at particular values. Then that is the mathematically you are doing by trial and error method, and how much time it takes, you know that. But if you go through literature based on different techniques, they said to get this minima or to get this so and so, the competition load is this much, the time taken is this much, the error is this much, like that. They are mentioned already when you use this technique. So when you come up with a new algorithm, you also apply on the same function, and you should say my algorithm is taking compared to your literature survey maybe one millisecond less, or maybe same time but error is less. So like that, if you compare, then people will appreciate. So like that, you have to motivate the your boy. Then you can see that, okay, already this is discussed very detailedly. I'm not touching. So to solve the problem, we are going to concentrate Woodward Lawson method, Taylor's method, Fourier transform method, Dolph-Shevchev method, and all these techniques are well known, and it is you can get this how to solve the problem using these techniques in any standard antenna book, either Cross or Balanis or and all these things. With the help of this, we can design your array and all. You can compute the weights, but takes time. And even if you are taking less time, but if it is your user is moving, again you need to calculate it, because it is not fixed. Time to time, the beam is going to be adjusted. When you want to adjust the beam, and you need to adjust the weights. So that computational weights it can be done with the help of these methods, but these methods will take some time. So to avoid that, one has to go for optimization techniques. Then you have to see the traditional and classical methods, steepest descent method, Newton's method, and LMS algorithm. These are very simple and easy to implement, but it has its own drawbacks. LMS may struck at local minimas, but it is a simple, but it will stuck at local minimum. Then the other drawback is slowly converges, and this convergence is mainly depends on the step size. Then this is the block diagram. Your overall beamforming block diagram, and your signal is going to be intercepted by these antennas, and the output of this antenna is coupled to the adder, and finally get the output y of t. So before going to couple, your incoming signal x of t is going to be adjusted by the weight vectors. So with the help of these weight vectors, we are going to get the desired pattern. So here one feedback mechanism is there, and using in between output and these weights, we have a highly sophisticated DSP plot form. So with the help of that, we are going to compute the weights to get the desired pattern. Then what are the applications? We can see the n number of applications: radar, sonar, communication, imaging, exploration, geophysical exploration, and astrophysical exploration, and biomedical, and so on. And now we are going to focus on especially in the sector broadcast and directional transmission, in the satellite communication and all. In the communication area, we are going to focus. It can be used in a number of applications. Then one should have overview of the antenna parameters, because when you are going to use these techniques in a antenna domain, you should have a good command on these parameters. Then control parameters to get the desired pattern. What are the parameters can be adjusted or modified to get the pattern? Then similarly, you can see the synthesis, pattern synthesis techniques and all. Then finally, the smart antenna. Then these are the important parameters. Uh, Anyhow, the boy has studied in a third year itself. He has to recollect it once again while doing this project. So radiation power density, then directivity, gain, efficiency, beam efficiency, bandwidth, polarization, all these things. So once you have good command, then your cost function is going to be defined easily, because in the cost function, then one of these parameters are going to be used to control that. Then we have a radiation lobe. We can see that this is the Cartesian plane, and the radiation pattern, how it is. This is the main beam, and these are the side lobes. All these side lobes are going to be controlled for this application. So based on the application, don't think that always side lobe should be minimized, or always a main beam is. So sometimes you need 360, sometimes only a particular direction. So based on the application. So this is the main beam, and these are the side lobes, and these are the side. This is the back lobe. These are the side lobes, and this is the field pattern. This is the this one is field, and that one is power pattern. So, so like that we can do. And here we need to control the side lobes, and we need to place the null at a particular unwanted signal direction. You have to identify, and you have to place the forcefully null in that, so that interference is minimized, signal to noise is going to be improved, and that leads the quality of the signal and bandwidth also. Then a single element is a relatively is a wide radiation pattern, and gain is compared to low. So the directivity is low, gain also will get less. So if you want to transmit the signal for a long distance, what is the solution for this? So once if you study, uh, then uh, we have to increase the electrical size of the antenna. We have to increase the electrical size. But simply increasing the electrical size, structure will be very huge one, and may not be advisable. And it has own demerits. We can construct, but maintenance and other things we can't carry on all. These are the things, the drawbacks. So nowadays the system is very small and all. You have to install your antenna on the system. So antenna on the chip. So they will give the specific area in that you have to you have to develop the your antennas should fit into that. So for that, sometimes small antennas can be grouped, and you will get the required gain. So here a small unit is arranged in a systematically to get the desired pattern. So this is for cellular mobile communication. So group of antennas are connected in a systematically. Then we'll achieve this. Then control parameters. To shape the overall radiation pattern, these are the parameters are available to control the radiation pattern. One is geometry. Geometry in the sense that you can use a R antenna or a dipole antenna or helical antenna. What are the structure? Either patch antenna or so. What are that fractal antenna? So you have to take that antenna and we arrange them in a, linearly or in a circular fashion or in a planar form. So how we are going to place them? Uh, so that is handles the geometry. So whether they are arranging in the line in a linear fashion or in a circular fashion or a triangular, or what is that? So based on that, performance is going to be modified or going to be decided. Then another parameter is D, inter-element spacing between the elements. So once we decided it is a circular or is a linear or a planar, whatever that geometry, then what is the spacing among them? So is it 0.5 or 0.25 or zero point 0.7 or zero point 0.8, and need not be always constant. It may be a variable. So whether it's uniform spacing or non-uniform spacing, and once if it is non-uniform, how to achieve that to get the desired pattern. So 0 0.1, 0 0.3, 0 0.7, 0 0.5, 0 0.4, like that it is there. So how to get it, these values? So for that, you have to define the cost function, and you to get the desired pattern with the help of the cost function, you are going to compute the weights. And while computing the weights, you are going to use the optimization techniques. Then we have the current or voltage, simply can call it as amplitude. Amplitude can be adjusted, so and also can be modified. Phase, with the help of control of this parameter, we can achieve the desired pattern. And another one is a pattern. So we can take the all our dipole, all our horn antenna, all our dish antennas, or a combination of that. But how to do that? So how to select it, and how to design all these things uh, is a very important thing. So you have to concentrate these 5 parameters and handle these parameters in, systematically to get the radiation pattern. Are you got the point? Or then smart antenna system consisting of number of elements whose signals are processed adaptively to exploit the spatial dimensions of the dynamic mobile radio channel. This is the definition of the smart antenna system. In some books, they are giving in a different way. So this is one of the standard definition for smart antenna system. Here, smart in the sense that not the system appearance is smart, the behavior is smart. So this is very important. So dynamically we can control the adaptively you are doing. That is meaning of the smart. So we can adaptively control the weights to get the desired pattern. Then system model and adaptive beamforming techniques and DOA estimation. Then we can arrange in a circular or planar. Okay. Now already we are discussed, so I'm not going to touch it again. So arrange the antennas in a linearly. The output is y of t is equal to w into x of t, and these weights are going to be controlled with the help of LMS, and LMS can be applied in a prediction, equalization, echo cancellation, identification, and filtering programs. Yeah. Then the next value is equal to present value plus the step value into different signal. Then we'll get the next value. This we have discussed last class very detailedly. And before going to design any algorithm or going to develop the steps involved in that algorithm procedure.
Yes, sir.
Yeah, in any place? Yeah, in it. Okay. Now you have to concentrate convergence, cost function, rate of convergence, and computational requirement and robustness. So convergence means once you are run the program, you will get to some value, maybe 0.5 or 0.3. So that value should be stable. It should not be vary. So that is meaning of the convergence. So when you are sometimes you are going to say, I'm expected the value is say 0, and based on my algorithm, I got the value is 0.5. So it is very closer to 0. So I'm very happy it is converged. If we say like that, the boy never will understand. So here, the convergence is very stable or not. That is very important. So when you conduct the test for a boy, he got it 50 marks. Then based on that, we can't certify he's the average student. The other boy got it 90. Another boy got it 10. So the person who got 10 marks, you can't say that the boy is very dull, and the person who got 90 is excellent. Based on one test, we can't certify that fellow is good and this fellow is poor and that fellow is the average boy. So if we conduct continuously some n number of tests, and if we see the performance and take the average, and from that we can say this is the average student, this fellow is a below average, and that above is excellent student, like that. Like that we can say. So whether his performance is constant throughout the all the tests, that is very important. So simply, and sometimes say you are conducted 2 tests, and in one test one boy got 100, another boy got 50. Another test one boy got 0, another boy 50. If you take the average, both are got same. 100 plus 0, yeah, 100 by 2, 50, and another by 50 plus 50, 100 by 2, 50, and both are got 50. And which boy is excellent? Though the person who got constant performance, showing constant performance, that is the important. If you give a good training to them, that fellow will shine. But this fellow, one test he got 100, another test 0 means he is not consistent, and he is not having interest, he is not having stamina. All these things are reflecting. We have to be very careful. So convergence you have to explain, and cost function, then rate of convergence, how fast it is completed. So sometimes you have conducted a test, one boy completed and he got say 60 marks, and other boy will say, sir, if you give 1 more hour, I will also get more than him, like that. But he is not good performer, because he has to complete the task within the time bound. So the rate of convergence is also very important. You should get the efficient and effectively. So this is very important. Rate of convergence also is important. Computational requirement. So to complete the task, number of operations should be less, and it should be robustness. Environment. You are tested in the laboratory. It has to work in the industry also. No, it will work only in the laboratory means is meaningless. So irrespective of the channel behavior, it has to work. So while designing the laboratory, you have to take the practical channel conditions into account, and you have to design. Then your robustness will improve. So like this, you have to consider all these parameters while developing the algorithm: convergence, cost function, rate of convergence, computational requirement, and robustness. So if this is not giving performance, then your algorithm is not going to be suitable for the in a particular application to use that, right? Then LMS algorithm steps are involved. Y of n is equal to like this, product of your weighted signal. Your signal is weight multiplied with the W of h, and error information means objective function, or what you call cost function. Error E of n is equal to dn minus Y of n, desired signal minus output signal. So once these two are equal, then your output is 0. Once it is output is 0, you are asking to stop the algorithm. So the weight updation, initial value plus the step function, and this one. If the step is very, very large, and it takes less time to converge, but error will be more. If the step is small and convergence takes more time, but the error will be less, performance is good. So you have some trade-off among them to select this mu value and all these things. So you should concentrate whether you want to performance error should be less, and you want to get a better performance, then step size is small. But I want to quickly, then step size is large. But you have to compromise with the error factor. So these are the important. Example, say you are holding the number 10.5 or 10.4, and your step size is 1, then how many iterations will take? Around 10, 11. So you started at 0, then again you are taking the error negative, then 1, 2, 3, like that. So after 11 or 12 iterations, he is going to reach it. He is going to reach. So now with the step size is 1, you need around 11 iterations. If the step size is say 5, then 0, the next is 5, next is 10. So within the 3 steps, you got it. So you should explain like this. Then you have to be careful. If the step size is still small, then error will be very, very less. So earlier, what is the error? Is a 0.5. Then if the step size is 0.5, then finally when it is converged, error will be 0, because 10, the next iteration 10.5, error will be 0. So but in the previous case, always this is incremented by 1, and then error will be always existing. So it never be 0. So you have to be very careful. If you explain an example, then boy will understand easily how this parameters will play a role in optimization. Then normalized LMS algorithm, here your mu values depends on the signal. So here this is not this is independent here, and in this case in the normalized LMS, a function of the incoming signal. Sometimes your incoming signal may be zero, or your autocorrelation function of your signal may be zero. Then your mu will be tends to infinity. That should not be happen. So that is why we are going to add a small constant. So with the help of this small constant, positive term, this never become zero. Then we can see that these are the results. I'm not going to touch. Already we have discussed. These things already discussed. Yeah. So now genetic algorithm, briefly we'll see. It is a heuristic search algorithm. Heuristic means the solution candidates or the population themselves, they are going to updating their performance by iteration. So that is why it is called heuristic algorithm, and it provides efficient and effective techniques for the optimization. That is the reason people are going for the genetic. Why people are going means it is efficient and effective. Uh, you are going to get the value and quickly. The error is there. Say you need to get 0.5, you will get in 0.4. The error is 0.1. Okay, you are going to accept it. It is acceptable range. So you are completing the task and effectively and immediately. So that is the reason people are crazy to use the genetic algorithm. Then what are the steps involved? Chromosome construction. This is very important. So the selection is very important. If you are not going to construct the chromosome, then you have to struggle, and sometimes you are not going to get the output. Again, you have to redefine. So selection process is important. So if you are not going to say simply selection is important, and then the boy will never understand. You should tell that the difference. Say for example, IITs, their selection is quite tough and quite higher compared to all other universities. That is why they're getting best students, and their package is also quite different. And if you take the NIT, their selection is also different. Their package is also different. If you go to the universities, the universities, their packages are, why these packages are different? Because of their inputs are different. So their performance is also different. Don't think that all are good. Just globally, if you define, then the boy will understand. Oh, the selection uh, name. So if their input is slow learners, isn't that without this criteria, simply they have taken from the they picked all the boys from the slow learners. Then whether they are going to get the same name? No, it is not possible. So selection is also very important. So here also you have to construct your chromosome in a properly. So you have to study the problem and construct the. This is a very important step. So once the construction is over, you have to initialize, then selection. So you have to select it. Simply getting the students is not enough. So they got all the best students in NIT, IITs and all. And okay, then there is no proper selection step by step. Then again performance will come down. So again, you have to conduct the test in a systematically and periodically, properly, and the quality will improve. So that is why I said, if you understand the subject thoroughly, then you can know that the importance of the exams. Nowadays, people are thinking that exams are very burden, but unfortunately, education system is entering into commercialized, and it is the students are getting in the bad image on the exams. But without exams, how you are going to evaluate? How do you know that they are followed? So there is no good feedback. So with the help of the exams only, we'll get the feedback, and based on that, the right teacher will take the necessary steps to improve the student performance. The performance is going to be improved. The understanding level is going to be increased. So selection is very important. Then after selection, the crossover is very important. So some initially some population is going to be selected and some of them are going to be rejected. So you have to fix that some threshold level. Above the threshold level, you are going to accept it. Below is discarded. Say, how can you say that if the boy is passed? You are fixing 35 marks. Above 35 is passed. Below 35 is discarded. So again, you are going to give the special training this group and another training another group. So it is not uniform. So to improve the overall performance, again, based on these results, you are going to work out. So similarly here, you have to take that. If the below the performance, you have to discard it, and above the threshold level, you have to select it, and if necessary, you have to apply the crossover and mutation to improve the further. So after that, after changing the chromosome construction, sometimes it will give the better results, sometimes may not. So how do you know that whether it's giving better results or not? Again, you have to conduct test again with the help of the test, and you have to see that cost function response, whether it's giving better or not. If it is better, you have to accept to the next level. Otherwise, you have to discard it. So like this, all these steps are involved in our day-to-day life also. That is why I said in the beginning. So if you observe the nature thoroughly, and you'll get an excellent mechanism. So that things you have to motivate to the boy. Then what are the steps involved? Chromosome construction, generation of the initial population. You have to evaluate the fitness. So all these initial population pass through the fitness function. So you have to define properly. This is very important, fitness function. Say you are delivered the content and you prepare the question paper in a dead easy manner and very simple. Then everybody is going to answer. The boy who has attended the class and the boy who missed the class also will answer. Then what is the fun of the conducting the test? So to evaluate that, your test should be in such a way that to what you call to test it their quality. So you have to test it their whether they understood or not. Accordingly, you have to frame the question. Similarly, here you have to define your cost function properly. What you are expecting, what you want, which parameter you want to control based on your problem. I want to control side lobe, or I want to place the null, or I want to improve the bandwidth. I want to do this. So understand the problem. Based on that, you have to define your fitness function. So this is very, very important parameter. Very, very important. Now, most of the time, people will fail here only. Fitness function evaluate. So once if it is fitness function is defined properly, and all these populations are passing through this fitness function, then you have to see that their rank, how. So now next step is selection. So here so many techniques are there. And these are the standard techniques: rank method, then Boltzmann selection method, then tournament method, selection method, then roulette wheel method. So many, etc. So many are available. So you have to pick up one according to your problem and select it. Once you got it, then if you are getting best results, you have to stop. Otherwise, you need to adjust something. Say last class we discussed it very detailedly. You are selected 10 students, then you need only two. Then you are going to give some training these 10 students, and they will perform nicely. So similarly, here also you need to modify. So you are taking the initial population that is called as old population, and you are allowed to go for the next operation before going to for next generation. The next operation, you are going to apply the crossover and mutation. So with the help of these operations, you are going to develop the another generation that is called as a new generation. So the old generation is slightly modified with the help of this. So the castings of the chromosome is going to be modified to get a better result. Once it is good, you have to stop. Otherwise, ask them to modify. So then this is another one. This already we discussed last class. Take the Rosenberg function. Say assume that D is a 10. So 10 is variables. So dimension is D is 10 means 10 dimensional Rosenberg function. If it is 2 means 2 dimensional. Right now it is a 2 dimensional, and this is the or in the center is my output. So to get this, hello, is it following? Okay.
Yes, sir.
Okay, sir. Okay,
Yeah,
sir.
good. Then after few iterations, all these particles or the populations are moving closer and closer, and finally will be converged. Sometimes it is closer to this. Once if it is closer to this, and if we are happy, and if the error is very less, and you are going to ask them to stop, and that value you are going to consider. So here I said in the beginning, this Rosenberg function, when you'll get the minimum is 0. Sorry, when you'll get the 0 when x is equal to 1.
Sir, I'm not understanding, sir.
Huh? Okay. Then the genetic algorithm, the crossover. So before crossover operation, so assume that your value is 175. Then another value is 240. These are the two values before crossover. When you apply in a binary form, it will be like this. When you apply a crossover technique on this chromosome, bits are mutually interchanged. Then all ones are replaced with all zeros. All zeros are replaced with all ones. Then before crossover, it is 175 and 240. But now this is I can call it as a old generation or old population. So this with operation of crossover, you are getting 160 and 255. I got the new population. If it is good, you have to accept. Otherwise, you can discard it. Then it need not be exactly in 4 bits. It may be 3 bits or maybe 5 bits. Based on the application, you can select it location. Then mutation operation. Right now, I have shown 1 bit. Need not be also 1. It may be 2 or 3 or different locations. Need not be always the last bit. It may be first or in the middle or anyway any location. So based on the application, you can select it. And for time being, we are considered as the last bit. And then 170. For 170, this is the bit pattern, and the last bit is modified after mutation operation. So 0 is modified to as a 1. So put to 1. Have you got the point or not? So with this, your chromosome value is changed. Basically 160, 255 and 171. It is not existing in our old chromosome. So after crossover and mutation, new populations are existing. So if the new populations are good, you have to accept for the next iteration. Otherwise, you ask them to modify. Still, if it is not good, then you have to change the completely your initialization. Then these are the some specifications. Here consider 20 elements and spacing is 0.5 lambda. Desired direction is 150 degrees. Then unwanted signals at 50 and 100. And similarly, hybridization. So you can mix the LMS and GL and so on. Then we can see here at 150, we have the radiation pattern, main beam. At 150 degrees, we have the desired signal. Main beam is at 150, and unwanted signals at 50 and 150, 100. At 150, sorry, at 50 degrees, look at here, at 50, unwanted signal, and similarly at 100, also unwanted. Then this is the standard LMS. Using hybridization, we got the better performance. When you compare with these two in a radiation pattern in this field, it is very difficult to understand whether it is giving better performance or not. So for that, we have to go for convergence plot. This is the from this we can understand whether it is giving better performance or not. See that here it is converged at around 20 iterations. It is converged, but this is due to local minimum problem, and after that again it is deviated. It is not stable. Your convergence is not stable, and still it is very, and later on the error is decreasing, and around at 100 iterations you got the better performance. But when you use the hybridization, you can see here after 60 itself your performance is almost constant. It is stable, and here also you have the local minimum problem because of LMS algorithm, and slightly is deviated. So but you can see that deviation is very high here, and here the deviation is very less. And you can see that before training, the boy performance is highly random. After training, the boy performance is now is a constant performance. So that is the difference. So you can see that with the help of these operations, we can change the behavior of the particle or the population, because in some algorithms they are going to called as a particle, in some algorithms they are going to call as a population, some algorithms they are going to call as a candidates. So all are same meaning. Then you can see that the weight updation with in a standard LMS algorithm, for one weight will be like this, highly random nature, and this is the smoothly converted to final value. So these are possible when you see that iteration by iteration only. But in the final output, if you go to back and I can't see all these things, I can't get the information. So from this plots, we can analyze the how the algorithm is performing in what direction, how it is and all. Then the tabulation you have to give all the parameters, and you can compare. From that you can list out which one is the best one. Then you have to see a DE, a differential evaluation algorithm. This is very important one, and this is one of the population based research heuristic algorithm like GA. Uh, then you have to see that, yeah, this is the block diagram of smart antenna beamforming concept, and your antenna is going to receive the signals wanted, and also going to receive the unwanted signals, and you need to place the null in unwanted signal direction, and these weights are going to keep on going to be adjusted with the help of D algorithm. Then what are the steps involved in a DE? It is a heuristic global optimization technique. Then here, almost all the steps are similar to your GA, like GA, initialization, then mutation, recombination, and selection. And there also is like that. You have to initialize, then selection is there, then mutation is there, then like that only. So more or less is the same. That is why I've said once if you study 4 or 5 algorithms, then understanding the next one is very simple. So in the beginning, it takes reasonably some time, but once you understand 4 or 5 algorithms, then analyzing the next one is very simple. So you have to motivate your boy to go through at least 4 or 5 algorithms to have a good command on this in this direction. Okay, before going to apply in a specific application. Now we have to see initialization. Uh, Here, the terminology is the target vector. It's called as a target vectors X. Initial vectors. So we have to define the initial vectors, and with the help of these target vectors, we are going to get the final results or your weights for your problem. So you have to initialize. Say for example, your Rosenberg function. So you are going to initialize. X is 1, y is equal to. Those are my 2 vectors, x and y. So what are the values? And finally, to get that value, you have to apply this DE. So you have to define target vectors properly based on the problem. So y means based on the input range, and you have to define properly, and how many populations you are going to define, that you have to do here. Once initialization is over, then you have to go for mutation. So this mutation expands the search space. Here, say for example, take the one function, Rosenberg function, 0 to 5, and 0, 1, 2, 3, 4, 5. So how many levels are there? 6. Then similarly, y-axis 0, 1, 2, 3, 4, 5. So 6 points. So total how many points will come? 6 into 6. 36 points will come. So with this 36 points, can I get the results? May not, I don't know. So to get the value, all the 36 points, 0 0 0 1 0 2 0 3 0 4 0 5, similarly 1 1 1 2 1 3, like that, all coordinate values x comma y. So your x is varying from 0 to 5 and y is also varying from 0 to 5. Total I have 36 points will come. All these 36 points you have to apply, then only can came to know that where is the your answer. And we'll get the 36 results, and you from that you can see, oh, this 1 1 is giving minimum value 0, hence this is the answer. Even you got the answer also, sometimes you may get somewhere else also. So we don't know whether the better results will come in another combination, or is there many multiple answers. So until to complete entire operations, you can't decide where is your answers and all. So we need to much time. But 36 is very simple. But if we take that fractions, 0 0.1, 0 0.2, 0 0.3, and so on, then how many points are there? Infinite points. Earlier it is a discrete 0, 1, 2, 3, and all. So only 36. But need not be into the account to get the accurate value, and your test points are infinite. So by trial and error method, you may get the results maybe first iteration, or second or third, and so on, or at the infinite iterations. Even in the middle or in the beginning, you got the results also, you are not going to satisfy, because in the future you may get the best results. Based on the psychology, human psychology, you are not going to be happy until it has completed all the test points. You know that when you go to select the test, the show the some sets to you, or some shots to you. You actually want one. He has dropped on the table 10. From that you have to pick up, but you are not going to happy, because you are looking on the cupboard or in the bureau. There are so many shots are there, and you are asking, show that top, show this one, show that one, this one, like that you are asking. You are not going to happy unless he has to show all the things. Got the point or not? So actually in the 10 itself, it is there, what you want, but you are not happy. You are asking to show. Finally, from the first 10 only, you are going to pick up one. So we don't know whether the desired one is this one, or there on the cupboard. So we need to go through that. Similarly also, so where is the result is there, we don't know. So we So your initial population, don't think that the initial population is infinite. You are going to start the algorithm, maybe 10 or 20, or worst case 100, or the worst maybe 1000. So you are going to start the problem with a limited number, maybe 100. Most of the times 100. In general, 100 points. So from the 100, you are going to get the desired value, and by iteration, these 100 points are going to be modified by themselves with the help of the cost function. Are you got the point? On finally you'll get the desired output. So that is the beauty of the algorithm. So you have to initialize the target points. Initially some 100 points, 100 vectors. Here I'm going to call it as a vectors. There it is points. Is a population. Now we are going to say what do you call in LMS is weights. So definitely the algorithm to algorithm terminology varies. So you have to initialize the target vectors X, and with the help of the mutation operation, you are expanding the search area. So initially it is 100, and with the help of the mutation, you are going to get the further search. So you are going to improve the your solution, and with this mutation operation, you will get the new vector, and that vector is called as a donor vector V. And later, sometimes you are not happy, and further you want to improve further, then we are going to do some operation on X and V. We are going to do some operation on target vectors and donor vectors. So you are doing some recombination operations and all. with the probability crossover CR. So with the help of the probability CR, we are doing some operation on these two vectors x and y, and from that we'll get the resultant vector, and that is called as a trial vector. This entire process is called as a recombination. So in the recombination operation, we are going to parameters in the x, certain parameters from the y, and sometimes both can be taken, or sometimes few can be taken. So anyhow, so based on the recombination operation, we'll get the trial vector. Then once you got it, then you have to select whether it is performing well or not. So again, you need a cost function or some what do you call fitness function. With the help of that, we are going to select it for the next operation, next iteration. Once you are getting best, you have to stop. Otherwise, ask them to repeat the all the 4 steps. Now, I'm giving one example here, how the mutation operation is going to expand the search space. Initially, we have a 3, 2, 1. See, look at here. This is the x stands for initial vector. So xr1 is the initial vector. G is the generation. So first vector, then second vector, then third vector. So for time being, I have taken 3 vectors. These 3 are random. These 3 are randomly. What are the values? Those values are 1, 2, and 3. So x1, xr2, and xr3 all are random vectors and initially defined, and you are taking randomly. Those values are 1, 2, 3. These are existing. But using mutation operation, I got 3.7. See that it is explored. The area is going to be extended. I got the new parameter, new value. It may be a possible solution or not. Doesn't matter. So based on the cost function, I'm going to decide whether it is a feasible solution or not. Right now, I have the candidates 1, 2, 3, and I'm not happy. I'm not getting the results. So I'm applying a mutation operation. So when I'm applying mutation operation, I got the 3.7. So I'm exploring my search area. I got the point or not? So this is the beauty of the mutation operation. So how you are extended your search area? So I'm going to take the difference. Randomly, I have selected 2, 2 and 1, and XR2 and XR3 both are differenced, and that difference weight vector is multiplied by some constant. Here, this is the mutation factor. F is called as a mutation factor. So this value varies from 0 to 2. So right now I have taken 0.7. So 2 minus 1, 1, 1 into 0.7, 0.7 and plus 3. So totally 3.7 is, we got it. So the difference vector is added to the initial vector. You see that this is my initial vector, XR1. XR1 is modified with the help of mutation operation to explore the search area. So that is why we can call it as it is expanding the search space. So this is the mutation operation. Then a number of elements 20, spacing is 0.5 lambda, iterations 100, initial population. In this case 15 only. See that the beauty. Just from the 15, we are going to get your desired output. So in general, we have infinite population, but finally you are going to take 15 only. Say why you are conducting the MSET or mains and all, your possible candidates are lakhs of students are existing, but you need only 10,000 or 1,000 or 1 lakh. From lakhs, 10 lakhs to 10,000, we are going to conduct the tests and all. Similarly, you have to be very careful. If once you understand the problem, then you know that how this algorithm is performing nicely. Then initial population is 15. Then crossover is 0.8 and constant value 0.6. This constant value is mutation factor. It will expand the search area, exploring the search area. And this crossover is to get the recombinational output. You can call it as a, you can go back and see trial vector. So to get the trial vector, you are going to use the crossover 0.8. And this crossover is going to be applied on the initial vectors and mutation output. Then a radiation pattern for the 20 elements linear array, we can see that two nulls in this case considered, one at 25, the other one is at 45. So exactly at 25 you have one null, and exactly at another 45 degrees location we have the another deep null. So around minus 50 dB. So very deep null. Normally all the side lobes are less than minus 30 dB. If you refer any standard textbook, you can get the 13 dB. Then you need to maintain all the side lobes should be still much smaller. So to minimize the error, noise effect and all. So all the side lobes are below minus 20 dB. Then both side lobes as well as the null. So one null at 65 degrees, all side lobes are going to be controlled. So like this, a number of cases you can study and so that you can have idea how the algorithm is performing in this direction. So the three nulls are considered 30, 45, and 60, and deep nulls are at 5 strategies, the responses. 1, 2, 3, you can see that pink color, then green, dotted blue, solid blue, black curve responses. So among them, which one is one? The dark black curve is best one. So strategy 5. What is the strategy 5? Here you can see. Strategy 5 is DE slash best slash 2 slash exponential. So how to understand this? DE means difference evolution. We are going to apply a difference among the particles, among the vectors. That is the meaning of the DE. The best, which vector is going to be modified? That is the meaning of that. Then how many times you are doing? That is this third one. And what is the nature? Whether it is a binomial format or exponential way you are doing. So these are the steps involved in a mutation operation. So now one by one we'll see at least this 5. So DE, differential evaluation algorithm, you are going to apply difference among them, and the best. So you are initialized 10 vectors, and these 10 you are applied on the algorithm, and you got it. And out of 10, maybe the 5th one is good, or 4th one may be good. So how do you know that 4th or 5th one is good? You are performing all these things, and you are giving based on their values some ranking. So 5th is on the top. So you can say 4th and you are next time. This 5th may go down or may improve further. Sometimes again is improved. Chance also there. So in a first iteration, at the end of the first iteration, you see their performance based on the cost function. Based on the cost function, you see the performance at the end of the first iteration. Then identify so far the best one, which one is giving less error, and that is the best one so far. And you are not happy, this best vector you need to modify further, and this best vector may be closer to desired response. So you need to modify further. I am going to apply mutation operation one time. This one means you are going to pick up randomly 2 other than the best. This is the best, already got it. Fine, in the first iteration. To go to the next iteration, this best value is going to be modified by one iteration. One difference. So to do the difference, I need 2 vectors. So any 2, randomly pick up any 2 and take the difference, and the difference is vector is multiplied or weighted by mutation factor, and that value is added to the best. Then you are going to use the exponential nature. So that is called as a strategy 1. In the strategy 2, random. Rand 1 comma 1 comma exponential. So random value is going to be modified by one iteration. Then rand to best. You have the best value. From the random value you are going to pick up, it is going to be modified to the best and by one difference. Then similarly, this is the rand. Random value is going to be modified by mutation operation with it twice, and this is the best value. So far is the best in that present iteration. When you go for the next iteration, this best vector is going to be modified by using mutation by 2. So based on this concept, you go back to first one. What is this operation? So here this comes under rand slash 1, de slash rand slash 1, and exponential. So why it is 1? I am taking only one difference. This is the random vector, this is another random vector, and I am applying only one difference. So that is why it is 1. And this 1 is added to where? Initial vector, initial random vector. So it is a rand slash 1. That is the meaning of that. So now I can come back. So this one, rand slash 1. So which I gave in the previous slide is the rand. X1 is modified with the help of x2, x3. So difference of the difference between x2 and x3, the resultant value is modified, and the modified vector is added to initial vector. Hence it is called a rand slash 1. And here the strategy 5 means best. So far the best, and that is different. So 2 means I need 4 vectors. So already best is there. So x3, x2, x3, x4, x5. So 2 times difference is there. So x2, x3, one difference, and x4, x5, one difference, and the resultant is affected by scaling factor, and that is going to be added. So like this we are going to do. Then it is called as a best slash 2. Then this is a case study. You can arrange in the tabulation so that you can understand what is the null depth, side lobes, upward beam width, all these things. So from this table you can conclude, oh, this is the best one, or this is giving this way, like that. Then you can see that pencil beam and sector beam. Pencil beam is for point-to-point communication. Sector beam is for to cover the large areas. So same geometry is a reconfigured random. So your geometries remains for both the pencil and as well as the sector beam. So we are not going to use 2 geometries. Only one geometry is going to be used. And if you are able to adjust phases, are you got the point or not? Then you can have the one pattern. And if you are going to adjust both, and you can get the sector. So amplitude is constant and phase is amplitude constant, phase can be modified, and both can be modified. Then we can get the we can have a good control on the pencil and the sector beam. Then this is another case study. Then you can see that DE slash best slash 1 slash is a bin. The selection is here bin. And then the previous one is exponential nature. Then similarly you can compare with LMS and DE and see that performance, how it is and all, and you can explain. The next one is Taguchi. This is another important thing. Then this is based on orthogonal array. This algorithm works on orthogonal property based on orthogonality. So already you have seen the orthogonality in a communication or in the mathematics and all. Normally if you say orthogonality, when you are going to apply 2 vectors in perpendicular, then it is orthogonal, or if you apply cross product or a dot product, from the results we can conclude as this is orthogonal or not. Here also we have to see this orthogonal. In the next slide I will explain what do you mean by orthogonality here and how to see and all these things. So this algorithm runs on orthogonal array structure. This effective method, and the beauty of this algorithm is requires less number of tests to complete the task. So this optimization process requires less number of iterations. Here we are going to call it as a test or experiment. The terminologies are all same, but application to application slightly changes. Okay, so here we are called as a test or experiments. There we are called as iterations. Then apply, it can be applied in mechanical or chemical or electrical and so on. You can apply in non-engineering also. So don't think that these algorithms are only for engineering sector. It can be applied non-engineering, all, not only this Taguchi. What you discussed so far, all that can be applied in a non-engineering sectors also to get the optimum results. Okay. Then how to define the cost function. So here you can see that this is array factor, and if you refer any standard textbook, you will get it. And this is the exponential form, and this is the cost function domain. So both are same. This is one is the exponential domain, another one is the trigonometric form. We are expressing array factor. Then if it is even, your structure is even, means symmetry, then you can compute only 0 to n only, or 1 to n. So no need to go for 2 n. Say my n is equal to 20 and it is a symmetry at the origin. So no need to compute 20 elements, just to take the half of that. 10 elements is enough. So that is why here 2 times your array factor is going to be multiplied. So the array factor is multiplied by twice. So you need no need to compute the 1 to 2n. So 1 to n is enough. So based on the problem. So sometimes if it is not symmetric, then you have to work for 1 to 2n. So you should know that the background of the antenna also. So with the help of that you can do. The next one is fitness function. This is very, very important. You have to define. So in this case, we are going to control the side lobes as well as the nulls. So in this expression, the first term is controls the your side lobes, and this one is the controls the your nulls. So if you are going to assume that your main beam is say 80 to 110, so for example 80 to 110, so 0 to 80 degrees you want to control side lobes, and similarly 110 to 180 you want to minimize the side lobes. So you can use this summation, so 0 to 80 and plus again integration from 110 to 180. So with the help of this we can have a good command, good control on side lobes. And this is the array factor at particular location you want to minimize. So 30 degrees or 40 degrees or 60 degrees or 70, whatever that. So assume that at 75 error is coming, or at 60 is error is coming. So exactly at 60 degrees you want to place a null. So you have to define like this. So with the help of this cost function, you are going to minimize. Then how to study this Taguchi method? So here the standard notation is there, EPLT. So E means the number of experiments, P is the number of parameters, L is the number of levels, and T is the strength. This is the notation. One has to know that, and you'll see that how to understand this notation. Now, the standard Taguchi notation is like this: ln of 2 power k. So n stands for number of runs. To complete the task, how many experiments you need, or how many tests are you need. Run or test or experiments all are same meaning. So number of runs, ln of n stands for number of runs, and 2 power k. This 2 is number of levels per factor. In this case, 2. It need not be actually is 2. It may be any number. We can use another notation also, some constant value, p power k, like that. So this 2 power k, 2 stands for number of levels. In this case, number of levels are 2, and k is the number of factors. How many factors you want to control. Say for example, your array is 10. 10 elements are there. Then your k is 10. Your k is 10. And each element you need to feed either 0 or 1. 0 volts or 1 volt. So then it is 2. And assume that it may be 3, 0.51. So you can apply 0.51, 0.51, like that you are going to feed, or all ones, or all zeros, or all 0.5, or combination of that. So then it is 3 levels. So that is the meaning of that. Then A, B, C, D, 4 elements. Antenna 1, antenna 2, antenna 3, antenna 4. And you need to give the signal. And your signal is varies from 0 to 1. Varies from 0 to 1. 0 volts to 1 volt. Right now, you are going to feed the discrete levels, either 0 or 1 volt. Then how many combinations are there existing? Anyone can answer? Anyone can answer? I have 4 elements, and each element can be fed between 0 and 1. Either you can feed either 0 volt or 1 volt. Then how many feeds combinations I can compute? Anyone in a chat box, at least to give a response so that I can understand you are following. Please. How? No one? What happened? Are you following or not?
Is anyone is
Please
there?
answer.
32. Arun
32.
draws.
Okay. Okay. Then I have 3 elements. I have 3 elements. I have only 3 elements, A, B, C. Then how many combinations? I have 3 elements, and I can feed either 0 or 1. How many combinations I will get? Anyone please respond quickly? Arey Baba. Right. Then I have 2 elements. How many combinations? 2 elements. 4. Fine, fine, fine. When it is a small number, you are able to answer. If it is my number is 27 elements and the levels are 3, then how many combinations? Anyone can answer quickly without using the calculator? Anyone in the chat box? Number of levels are 3 and elements are 27. Number of levels are 3, elements are 27. Number of levels are 3, 0.51, and 27 elements, A, B, C, D, like that. Anyone? How many combinations in the power of at least? Anyone? Not 2 power 27, 3 levels, 3 power 27. Then you will have a crores of combinations. Yes, 3 power 27 combinations. Where is your answer? We don't know. So if you go for trial and error as good. If you go to trial and error method, we need to test 3 power 27 combinations. Manually, it is not possible. And even if you start after a few hours, you will fed up and you will irritated and you lose the interest. So here, now look at here. Now I'm explaining the concept. Right now, I have 7 elements. I have 7 elements. Element 1, element 2, element 3 are represented in a column wise. 7 elements. And each element is fed either 1 or 2. 1 or 2. So I have to go for 2 power 7 combinations to complete my task. But using Taguchi method, only 8 experiments are enough to get the results. That is the beauty of the algorithm. Look at here. Just 8 experiments are enough to get the results. How means, you can see this here. Out of 8 runs, 1 is repeated 4 times, 2 also repeated 4 times. Then here also, any column, you please check it. Any column, number of 1s is repeated 4 times, number of 2 also repeated 4 times, any column. Then similarly, if you take any 2 columns, 1 1, 1 2, 1 4, 1 5, 1 6, 1 7, or 4 5, 3 4, 2 3, any combination, any 2 you pick up randomly and see that the patterns are repeated twice. 1 1 repeated twice, 1 2 repeated twice, 2 1 repeated twice, 2 2 repeated twice. That is the orthogonal property. So if you are able to construct orthogonal property, then the number of from 2 power 7 to 8. Basically, 2 power 7 combinations are required, but with 8 combinations, we'll get the desired output. So how we are going to achieve this? Now you can see that level 2. Now I'm going to explain briefly the algorithm level 2. I have 2 levels, 1 and 2. Either I can feed 1 or 2. Here 1 and 2 means one value, 2 means another value. Need not be 1 and 2. So just one value is represented as a 1, 2 as represent, another value is represented as 2 to understand that. So I have 2 values, or you can consider as 1 and 2, doesn't matter. So your parameter varies from 0 to 2, say for example, 0 to 2. So right now I've taken 1 and 2. But your answer may be at 1, your answer may be at 2, or your answer may be in between, between 0 and 2. And how to get the intermediate values? Now I'm going to explain here. Look at here. Right now I'm taking 1 and 2, and level 2 is equal to maximum minus minimum by 2 plus minima. Maximum 2, minimum 1, 1 by 2, 0.5 plus 1, 1.5. See here, 2 minus 1 divided by 2 plus 1, 1.5. Then intermediate levels. I is equal to level 2 plus or minus LDI, level difference. Then what is the level difference? Maximum minus minima divided by number of levels plus 1. Number of levels, 2 plus 1, 3, 2 minus 1, 1 by 3. So 0.33. So I can add 1.5 plus or minus 0.33. So the step, then we'll get another level. So like that we are exploring. Initially I started 1 and 2. Then I am exploring my possible combinations 1.5 or 1.6, 1.1 or 1.5 or 1.8. So like that we can explore. So you can iteration by iteration with the help of the fitness function, you can modify these intermediate levels and you can get it. So finally can take the convergent value whether it is satisfied or not. So with this we are going to start. Now look at here. Yeah. So what are the steps involved in here? First, you have to identify the problem. That is why in the beginning I said, if you understand the problem, then solution is there in the problem itself. Try to motivate your boy. See, the study should change his behavior, his character. Study is not for to get the degree, not for the job. Study means it has to face the problem. So once if you give the proper study to the boy, in future in the life, tomorrow, boy can face the problem easily. That way our education should give the stamina to the boy. Unfortunately, due to commercialization, today boy is going for suicide and hanging and all these things are happening because the education is not in that way. So if the problem is studied thoroughly, then solution is there. That's why I'm saying not only the optimization technique. See, it is belongs to optimization technique. At the same time, it is generalized also, this statement. If the problem is studied thoroughly, the solution is there in the inbuilt. Solution is inbuilt. Don't think that solution will come somewhere else. So if the solution is not there in the problem, then you can't say that it is a problem. Right now, you don't know the solution. That's why you are saying it's a problem. But once the moment you got the solution, the problem is disappears. So it means that solution is there in the problem itself. As long as if you are unable to see the solution, then it is seems to be a problem. And once you understand the problem, then you got the answer. Once you got the answer, your problem is disappears. So in the before test, if you ask the boy, sir, maths is very tough, sir. Is very difficult to understand. Other subjects are very, very easy. But one teacher has explained very beautiful and easily. Then after that statement, then boy will say, "Oh, maths is very easy." The reason is based on his the way he's approached and he teached nicely and beautifully. The maths problem is simple. Once the problem is simple, and he said finally same. That's what I'm saying. So if you understand the problem thoroughly, then solution is easy. So identification is very important. So like that you have to teach. So most of the times people may not concentrate here. So look at here and concentrate. That is why all are in one color except this. Except this, all are one color, and this is a different color, because you have to identify problem thoroughly. And once we are able to identify thoroughly, clearly, and solution is there inside. Solution is there inside. There is no problem. Okay. Now, once you are defined and identified, then what are the factors are there? Identify. Then suitable OA. You have to identify OA. These all are part of in that only. Okay. You are separating one by one. Then design the experiment. Then you have to run it. Once you run it, if you got it satisfied result, you stop it. Otherwise, ask them to update. These are the steps. The same thing is happened in a DE. Same thing is happened in LMS. Same thing is happened in a GA. But path is slightly different. Approach is slightly different. But more or less is same. More or less is the same. Are you got the point or not? So we are going to prepare so many in items from the rice. The base item is rice only. We are going to prepare many things, many items. But if you know how to handle the rice properly, we can do n number of dishes and beautifully. So like that, you should explain the boy. Then boy will understand. Simply, if you are explaining the concept hours together, then boy will lose his concentration, because he's a human being. So every 35 minutes or half an hour, automatically, without his presence, he will lose the track. Except a few candidates, except a few students, those who have strong determination, strong control on their way of thinking. And most of the times, around 80% of the students, they lose their concentration, their interest after 30 minutes. But as a teacher, you have to motivate, and you have to bring back to the track, and you have to inject without their permission. So that is the beauty of the teacher. So for that, in between, you have to give the live examples and relevant to the subject. Don't give the unwanted, unnecessary jokes and all. So whatever you are going to give the explanation or examples should be relevant to the subject. Identify it is existing for each and every subject. Don't think that only these optimization techniques are you are comfortably giving an example nicely. No. Whether it is EDC, I used to give the examples nicely there also. So you identify for your subject and give the every 30 minutes 2-3 minutes one example, relevant example for that, so that boy will understand. He will correlate this example and that example. Sometimes it will be 100%, sometimes it's slightly deviation. So if you give the live examples in and around he's seeing, and he will remember easily concept. So without his permission, the subject will enter into his brain. That is the duty of the teacher. Present, it is not happening because we are busy with schedule. So you have to complete this much syllabus. You have to conduct this much test. You have to give the within the time. All these things. These are the reasons we are not concentrating. Okay, engineering level is okay, but even in the school level also, they are not giving more examples and they are grinding. So that is our other reason, especially lower classes up to 10th, 10 plus 2, they are not giving examples. They are grinding in IIT. So baseless is happening. So if we give the strongly examples, then the boy will understand the concept and they will appreciate it. And they will consider as you are a role model for him. So like that you have to teach. And if you take that lecture effectively, the boy will appreciate and he will never forget. So he will get interest also. So periodically you have to give the one examples so that boy will attentive and active, and without struggle will understand the subject. I hope that all are doing, but take it in a little bit seriously and actively. Then you can take the one example, L27. See here, L27 3 power 16. See, 16 elements are there. In this case, 16 elements. Antenna 1, antenna 2, 3, 4, 5, 6 in the column wise. 16 antennas are arranged in a linear fashion, connected in one after the other. Then these 16 elements you are going to feed. How many levels? 3 levels. 1, 2, 3. Means 0 volts, 0.5, 1 volt. Any value. So, for example, you want to control phase 0 degrees, then 90 degrees, 180 degrees. So your range is 0 to 180. Your answer may be between 0 to 180. Right now we are getting three values: 0, 90, 180. Is the standard values? No. Right now we are assuming that 0, 90, 180. And your answer may be in between also. Maybe is also. So we don't know whether 0, 90 or 180 are in between values. So to compute that, initially you started 1, 2, 3, 0, 90, 180. Then you are going to repeat it. And to get the best results, how many tests you are going to conduct? 27. See that. The beauty of this algorithm is how many experiments are required? 27. And you see here, how many times one is repeated? Anyone can respond? How many times one is repeated? 3 levels are there. How many times one is repeated in chat box? How many times one is repeated? 3 times, sir. My God. Out of 27, how many times one is repeated? Totally I have 3 distinction levels, 1, 2, 3. 27 by 9. How many? 9. Good. 9 3s are 27. So 1 is repeated 9 times, 2 is repeated 9 times, 3 is repeated 9 times. So you take the any column. You take the repeated 1 times. T1 is repeated how many times? 1 is repeated how many times? 2 is, anyone can answer? 1 is how many times repeated? In the chat box. Please respond. 1 how many times repeated? 1 how many times repeated? So that I'm happy. Yes, you learned little bit. So the purpose of the delivering lecture is fulfilled. 9 times. Oh my God. Arre Baba. Be careful. Be careful. 1 1, 2 1, 3 1. How many combinations are there? Totally 27 combinations. 1 1 itself 9 means 2 1, 3 1, 1 2, 2 2, 1 1. How many times repeated? Arre Baba. Anyone? 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 Sure? Answer is correct? 3. Is it correct? Yes, 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 like that, like that. So similarly, you take the any 3, any 4, like that. So if it is satisfied, then it is orthogonal. Don't put randomly as you like. That is not the orthogonal. Orthogonal defined already. So you take the 3 columns, then all the 3 should be satisfied. Results. Look at here. To get 27, these elements should satisfy orthogonal property. Then only you'll get 27. If this is not orthogonal, then you have to go for 3 power 16. Then lakhs of combinations will come. Not lakhs, crores of lakhs combinations. You have to verify. Then manually it is not possible. Then when you apply on the array factor, then you can see that. So main beam is here and the side lobes are controlled like this. You get it. Then this is a convergence plot. So you can understand then how it is weights are going to be. Like this you can see. Then the other one is question pattern, especially in radar applications and all, or even in mobile communication is going to be used question pattern. This is a fitness function. Again, you see that fitness function is different. So once you understand the problem, then accordingly fitness function is going to be modified. Don't think that always fitness function is remain same. So that's why I said in the beginning. So these are the simulation results. 24 elements, 0.5 lambda, then Taguchi is 27 comma 12 comma 3 comma 2. Then this is the outcome of the these results. Then this is your what do you call cosecant pattern. You see that if you try to plot the cosecant function in the trigonometric geometry, then the shape is like this, and it is called as a cosecant pattern. Why you need this cosecant pattern? If you take the class in your class of physical, get a reasonably dB level. If the last boy is make a comment, sir, I'm unable to hear, it is not audible, then you are going to increase a little bit based on your capability. Then finally, the class will go smoothly. In a small distance, you are managing. But if you want to take the same thing in auditorium, can you take the class? Yes, you can take. But if you take without any electronic system, then the first boy itself will say, sir, we can't hear, we can't follow. The reason is in the auditorium, the dais itself, some 30-40 feet will be there. And the first row itself, boy can't hear because signal is completely attenuated due to propagation. Then you have to use the public utterance system. So then you are using the speakers. Then when you are using speakers, then you need to control the dB levels. The person who very closer to the speaker, you should get the less, and the person who is sitting far away, he has to get the more energy levels. And the placement of the speaker is also very important. Simply if you are placing randomly speakers somewhere else, then echo will come, and finally it is a lot of disturbance. So you have to place properly in such a way that a complete hall, the energy more or less is a constant. The dB level should be constant. Otherwise, if you place all the speakers in one place, then it is a lot of sound will come. Sometimes I have seen in the auditorium, they are placing the speakers in all are at one place. That is different. For fun, they are doing. For in the functions, in some occasions, they are going to place all the speakers one place, and DJ, they are shouting like that environment is different. We can't take that example here. So if you want to maintain the signal level in a uniformly, the placement of the speakers in the hall also very important. So when you are going to place it, then the signal will go uniformly. Otherwise, it is noise floor is going to be increases tremendously. So that is one important. Then when you here, now you understand why am I giving this example. The person who is very closer to the tower or base station will get more energy. The person who is far away from the base station is getting less energy. The reason is due to propagation. As the signal is propagating in the free space, the signal is going to be attenuated. That we know that. So the person is very near to the base station is getting excellent signal, and far away is getting a less signal, and both are paying the same amount. This will also paying 300 rupees per month for calls, and that will also paying 300 rupees per month for calls, and both are paying equally, but you are giving justice. So this is you are not studied the problem thoroughly. There is so you are not charging indifferently. The person who is getting good signal, more amount. The person who is getting less signal, less amount. That you are not doing. Whether it's getting signal or not, whether its quality is good or not, doesn't matter. Once it is link is established, and whether signal is delivered or not, you are charging. It is unfair. Covers in a properly, and properly or not covered the area, and the problem is it is signal is not varying. The signal strength is not varying. You are transmitting, and it is due to the radiation, signal is attenuated. You are radiating the signal uniformly, and this is also drawback. So what you understand, based on the problem, the person who is very near to the base station should get the less energy, or demands less energy, because since it is very closer, the person is far away, demands more energy, so that both will get the same quality of the energy level. Are you got the point or not? So that is possible. You have to change the radiation pattern. You have to change the radiation pattern. The same thing. After this example, if the boy is unable to understand, you have to give one live example to the boy. Say for example, the person very closer to the water tank, they will get the more water, and maybe 2-3 kilometers away from the water tank, overhead tank, that colony will get less water. So in between the 4-5 colonies are there. In the beginning colonies, they will get the good pressure, and the last tail end they are getting less water, with less power, less pressure. But you are charging uniformly. Every month 60 rupees or whatever, maybe that you are charging every month. So it is inefficient. They are not studied the problem thoroughly. So it is discriminating. You are discriminating. So they are not studied. So the person who is getting less, they have to, you are charging less means okay. But finally both are paying the same amount. So the person very closer to that, they are getting more water, and it is overflowing, and water is wasting, and the tail end they are not getting. And similarly in the agriculture, those are very near to the reservoir or very near to the canal, they'll get more water, and the dead end they are not getting single drop also. But all are equal. But the reason is you are not studied the problem thoroughly. If you study the problem, then you can understand. Then periodically you have to control the water flow. Similarly here also, in the beginning you have to close these fellows, and you have to release them, and you need some mechanism, opening and closing among the walls. So this colony should be closed, and this colony should be open. When this is closed, this should be open. So nowadays technology is available. No need to go to the person to do manually. So using sensors and all, you can operate the controlling all these things. So if you even manually also, the boy has to, the worker or the relevant persons, they have to go and they have to control. If they do systematically, everyone is going to get it water, and there are no wastage of the water. Then what they will do, instead of pumping 1 hour, they are pumping 2 hours. So one side is what is wasted. Since these fellows are not getting, they are sending more time. So when you study the problem thoroughly, and then the problem will give you the solution. Accordingly, you have to do the solution. That is the reason you should educate your students in thoroughly, properly. You motivated, or irrespective of the problem, irrespective of the domain, your study should able to face the problem. So that is the meaning of the study. So here also, one fellow demands more energy, another fellow demands less energy. So the profile, the electromagnetic profile, the radiation profile, if you see that, it is a question shape. So that is the reason we are going to take the question pattern. Got the point or not? Hope that you understand this point. If you give the relevant examples, boy will understand easily. Then they will appreciate it, and that way you have to educate the boy. So almost we are reaching the scheduled time. Then I will stop here, and the continuation we'll see the other algorithms whenever the opportunity will come. So far you have seen DE and Taguchi method effectively. This is, and what is the point or not? So last class we have seen LMS and GA, and today we are seeing DE and Taguchi. In futures we are going to see the rest of the algorithms and all, DOA based estimation methods and all these things. We'll see coming classes whenever the opportunity is giving your organization. So when they are giving, if they like my lecture, they will give the chance to me to take. So definitely I would like to continue rest of the algorithms, because it's infinite. It is not possible to address all the algorithms at a stage. So I hope that you understand at least small delta, and that is enough for me. The purpose of the lecture is also be fulfilled. So if you have any doubts, please ask. So I'll try to answer. Few questions.
Thank you,
Any
sir.
doubts?
Thank you, sir.
Thank you, sir.
Any doubts are there? Participants? Sir, one question is actually only one question asked in the chat box.
Okay, sir.
Please explain the generation of coefficients by taking one shaped beam with the help of any algorithm.
Yeah, sir, that is possible. But again, we have to do some MATLAB programming and all.
Yes.
So whenever it is time permits, we'll give the hands-on also, sir. We'll plan.
Yes. Yes. Yes.
We'll plan, sir. Because
Okay.
with theoretically it is very difficult. So we'll plan,
Yes.
sir. Okay.
Yes. Yes. Sir. Thank you, sir.
Right, sir.
Any
right,
other
sir.
questions are there from the participants? You can ask now.
It is very, very interesting. So you try to motivate. See, need not be in antennas. These optimization
Yes.
techniques can be applied in communication, in VLSI domain, in between the routing. Because when you are running the cable from one node to another node, you have to find the shortest path. So simply, without these techniques, if you run the cable, we need more copper. So sometimes it is very difficult to run, and it leads the capacitance and inductance. So before going to run, between the two nodes, you have to find the shortest path, and for that you have to apply the optimization techniques. So n number of, even in our domain also, any subject, these techniques can be used to find the better solutions. And not only that, in a day-to-day life also, you can use these techniques to make a proper decision in that process. So hope that no nothing.
Okay, sir. Thank you, sir. Thank you once again for accepting in this STTP also. Once again, thank you very much, sir. Whatever your suggestions, if it possible, we will go for the one hands-on experience in the next.
Definitely, sir.
According to the convenient, sir.
All right, sir. Definitely.
Thank you very much, sir. Once again.
Okay, sir. Right.
So,
sir.
Participants, those who are having that not filled the attendance form, please fill this attendance. Attendance part is very important. And tomorrow morning, the session will start at 10 o'clock sharp. Thank you very much.